Hello everyone, very good evening. I hope I'm live now and you're able to hear me clear and loud. Can you guys please put that into the comment section to confirm if you are able to hear me clear and loud? Can you put that into the chat section, guys? Let me check myself on the YouTube if it is up or not. Fair enough. Am I audible to you people? Can you guys hear me clear and loud? आवाज आ रही है आप लोगों को? Very good evening, Deepak. Can you hear me? Am I audible? Can any of you confirm me if you can hear me clear and loud? Perfect. Thank you. I'll just wait for a few minutes. Thanks for joining on the Sunday evening. I know that this is the last day of the week. कल से Monday चालू होगा. And still you guys are able to make out time for this. That's kind of enough for me to understand that how sincere you people are for your career. So hello everyone. Very good morning and good evening to everyone who is watching from the different parts of the world. And hello everyone who might watch it later on, right? For those people also who is watching it later on when this live is done, hello to you. Thanks for joining in. My name is Vishwa Mohan and I'm going to talk about the different architectural patterns that we need to follow from the monolith to the microservices. We are going to demystify that in totality in the today's session. Perfect. So I believe let's get started since this anyway gonna stay on the YouTube, so we can get started here, right? So let me quickly introduce myself, right? So I am Vishwa Mohan. Let me take this pen. Right? I am Vishwa Mohan, people. I'm not a big fan of PPTs, right? So I'll try to keep it open slate, keep it open-ended. Anything and everything that we do in the today's session, we'll try to build from the scratch on this blackboard or whiteboard, whatever that you call it. और जैसा आप लोगों को चाहिए होगा, whatever that you guys, how the session build upon, I'll try to based on that. But before I get started, I need a buy-in from you people. I know that, sir, that this session is free. You are not actually charged any amount for this. But is it actually free? No, right? Because the next few minutes, next 1 hour, you might have to invest your precious time. And in the today's world, the time is money. So one thing that I expect from you people is that I understand this LinkedIn or YouTube or social media is very tough to focus. So make sure that next few minutes when you're watching it, try to make the best out of the time that you're trying to invest for this. If you're making the X amount of investment in terms of time, which is equivalent to the money today, make sure this time is worth, right? And how that can happen is very simple. Make sure that you sit in a place where you don't have much of the distraction and try to take out something out of this session. Make sure that all your doubts are being asked. I'll expect you people to maintain a decorum of asking doubts. Don't spam it. Wait for the time. Let me first complete all the topic because it is on YouTube. People can comment left, right. I might not be in a position to pick all those comments. So I'll give you enough time in the end where we'll keep more of like an AMA session where any doubts that you have, I'll be more than happy to answer that. But maintain that decorum so that in the beginning, we just cover all the concept. Can I expect that sincerity from you people? Can you say yes or no in the chat? I'll talk about all those things. Can I expect this sincerity? Can I expect that you guys who are spending time in this session will make sure that you get out something from this? आप जब वापस घर जाओ तो कुछ आप सीख के जाओ. Mostly I'll try to keep it in English so that everybody understand it. I'll try to keep it in a very simple English. तो अगर आपको ज़्यादा अंग्रेजी नहीं आती है, trust me, you will not have any doubts. Fair enough? Awesome. Very nice. So let's get started, people. So in the today's session, what I'm going to do is that we're going to talk about application architecture. What we're going to do, we're going to talk about something called as application architectures. if you look around, right, from so many years, we have been building the applications, the software applications. Starting from the monolithic to the today's buzzword in the market, which is called as the microservices. Right? If you look around, microservices is a hot word today. And if I talk about the monolithic, this is what we have been building for many years now. But the debate around ki kab monolithic use kare, when should I make use of monolithic, when I should make use of microservices, has been doing around for many years. If you remember, a few months back, Amazon Prime kind of released a statement where they said that when the world is moving towards microservices, when we move toward monolithic, it helps us save millions of the dollars, right? So in the today's session, we are going to talk about ki bhaiya hai kya ye sari cheeze, right? What is a monolithic architecture? What is a service-oriented architecture? What is a microservices? And when I go and work in the industry, when should I use which kind of architecture? So anyone who feels that they want to make it big in software engineering domain, anyone who wants to make it big in this IT sector, anyone who wants to work for the companies like Facebook or Google or Microsoft, any good product-based companies, understanding all these architectures, kya hai wo? When should I use it? What are the advantages of that? Understanding this is very super critical. And I am expecting by the end this live session ends, and if you stay till the end, I will ensure that yes, sari cheeze, everything around this, you get it crystal clear. You should have that confidence that anybody asks the questions around the interview in this topic, you should be able to answer it, right? So this is the topic that we are going to discuss today in a very simple, in a relatable manner. Fair enough? Am I clear, people? Does it make sense? Chalu kare, shall we start? Right, so let's start with something called as, the very first is called as a monolithic architecture, right? Let's start with something called as a monolithic architecture. Now, if I talk about the monolithic, sir, if I talk about the monolithic, the word monolithic comprises of two parts. One of the part is mono, another part is lithic. If I just talk about the simple English, mono means single, and lithic means structure, right? Typically a structure. So in very simple word, if I just try to understand the English behind monolithic, when you try to build an application where you try to keep everything at one single place, in one single code repo, in one single machine, one single deployment, that typically is called as a monolithic architecture. It means that single place. This monolithic architecture is believer of the proverb that we have in the real world, which says that unity has strength. Do you guys remember that old story that we used to study in the school, right? That there was an old farmer, he had 5 sons who used to fight among each other. So when he was lying on his deathbed, he asked his sons to go to the jungle and bring the clog of woods. And then he asked all the woods to be bounded together and told them that, can you break it now? And none of the sons were able to break it. And what was the moral of the story? The moral of the story was that unity has strength, right? So basically this monolithic architecture, since everything in the world of software is always inspired from the living world itself, they also believe of the same fact that unity has strength. So one simple takeaway from the monolithic architecture is that when you try to bring everything together in single code space, as a single repository, in a single machine, in a single programming language, that kind of architectural patterns is called as monolithic architecture. Let's try to understand with a more better example. In the today's world, we are talking mostly around the web application, right? In the today's world, we are mostly talking about the web applications, right? And any web application, what is a web application? Any application that you can open over a web, right? Maybe it in the mobile phones or maybe in the web browsers, right? Typically is called a web app. For example, of a web app could be, the applications like Facebook. It could be application like, for example, LinkedIn, right? Example could be Instagram. So these are the examples of the web applications that you have in the market. Now I have a question for you people. If I talk about a web application, what are the different parts of a web application, guys? If I have to ask you what are the three main parts of a web application, what will be that? Can you guys put that into the chat? As per one of the study, if you're watching a session live and if you interact with the mentor, your focus, your productivity goes up by 30%. Can you just, if you're watching it on the recorded way, pause the video and put that into the comments? Otherwise, I'll wait here. Can you guys tell me what are the three different main components of a web application? Can you put that? Can you guys put that into the chat section? What could be the three different layers how web applications are built in the modern world? कोई बताएगा मुझे? Very nice, Kaushik. Yes, Kiran, this will be recorded. It will be available over the YouTube. So web application comprised of three parts. Very nice. What are those three parts? One of the part is front end. Front end is a layer where your user comes and interact with your application. The another part will be the back end. The another part will be the database layer, right? So proponents of monolithic architecture says that the proponents of monolithic architecture, those people who support monolithic architecture, they say that if I have to build a web application in a monolithic architecture, then all these three components that I have, right? All these three components that I have, right? They all should come in a single machine. They all should fall under a single machine, means single computer. They should be written in the same language, same programming language. They should have the same deployment. So if I go and define the entire application like Facebook, LinkedIn, Instagram, or any other web application, how does a monolithic web application look like? Entire thing, the front end, the back end, the database, everything has to be written at the same place. So if I have to go and build a diagram for it, a typical monolithic application, if I have to go and talk about, right, it will comprise of, there will be a machine, a single machine. You will have all the layers. So in the single machine, you will have all the layers. So you will have the front end. You will also have the back end. You will also have the database layer, all in the same machine. Same machine. Same code base. Same technology or language. Same deployment. Instead of keeping all these things separately, it's a typical definition of a monolithic applications. In terms of a web applications, a typical definition of a monolithic architecture is that where everything is at one place. At the front end, back end, database, all of that goes in a single machine. All of that is kind of being managed with the same programming language, the same tech stack. When it comes about the deployment, everything get deployed together, right? When this happens, this type of architecture could be called as monolithic architecture. Am I clear till this point? Does it make sense? Am I clear, people? Does it make sense, everyone? Is everyone clear till this point? Bolo ha ya na? Fair enough? बोलिए. Perfect. So now since we have understood monolithic architecture, see guys, every time you understand any concept, जब भी आप कोई concept सीखने की कोशिश करें, first of all understand what it is. Because unless until you understand what, there is no point of learning anything. If you are attending this session, the topic first of all should be clear to you, because unless until that is not clear, you will not be able to understand why I am learning it. So once you have understood what, the second obvious point is why, and this should be logical. It should not be because I am telling you that you should learn this topic, you should learn. You should have a proper logic to decide that why should I learn these architecture patterns? Because in today's modern world, there are thousands of topics which is there. It's not practically possible for we as a human to know everything. So we'll have to prioritize. क्या सीखे क्या ना सीखे, right? So every time you learn a tech or anything that you do in the real world also, you should always try to go through the path of what and why. Through this session also and everything that I teach actually, I always follow this pattern. I'll tell you what and I'll tell you why and I'll tell you logically why you should learn it. So we have understood what part of monolithic, right? The next part is that why should I learn it? Why should I know monolithic? Or why should someone use monolithic? Or in other words, when to use monolithic? When to use monolithic? This is a more applied question, people. Many times in the interview when you go, understanding what is monolithic is good. But if you know that in what context, कब मैं इंडस्ट्री में इसको यूज करूंगा, when the situation will come where I go and make use of monolithic is a much bigger problem that you should be aware of. And you can have a lasting impact in the interview if you have this logical understanding that when a monolithic architecture should be used, why should one use monolithic architecture, right? So the next big problem that we're going to understand now is what are the scenarios, what are the situations. And I'll try to make use of all my experience. For the last 13 years, I've worked for all the big companies in the world like Oracle, PayPal, Walmart, Amazon, LinkedIn. Currently work as a CEO of PW. So luckily, I had a lot of experience working with more monolithic, service-oriented architecture and microservices. So I'll try to give my real-world examples also to understand that when or why a monolithic system should be used. So let's get started and understand when to use monolithic. When to use monolithic, right? And you can also term it like advantages of monolithic. Advantages of monolithic. But before I move further to talk about, I'll just give you a chance to put that into the comments. If you are right now watching, please put that into the comments. What do you think? कि भैया कब monolithic को use करना चाहिए? Or even if you feel that there is no point of using monolithic in today's world, you can also put that into the comments. So I want to hear from you people that what do you guys think? What do you think is the meaning? No, when should I make use of monolithic architecture? Any pointers? I'm happy to see your point of view, understand what you guys feel around monolithic. Can you put that into the comment? I'll just wait for a few seconds and see what you guys think. Just put small points. Any thoughts? When should I make use of monolithic architecture? Okay, very nice, Kiran. Anyone else? I'm wearing jacket इसलिए क्योंकि यार एक तो इतने सारे lights होते हैं ना, AC is running and I'm running actually cold. तो मेरे को सर्दी हो रही है. So that's why I'm wearing jacket. I'm not feeling well today. Thank you for the asking it. Very nice, Harshal, to create the new application. Single code base. Awesome, very nice. So one of the reason or the place where I'll start with the monolithic application is that number one, when I'm just starting, when I'm just starting, When you start building any application and you are not sure what the future of the application is going to be, you don't have much team members, you have a small team, you are just building an application, right? One thing which never get you wrong is that when you start with a monolithic application itself, almost every application that you see in the today's world, be it Facebook, be it PayPal, all these bigger tech giants, they all started as a monolithic system itself. So when you're not sure, sir, that when to start, when you're not sure that what to build for, you don't know what the future of application is, one thing which can never get you wrong is that you start with monolithic, and as and when you make progress over a period of time, you can always carve other architectures out of it. So number one point is that when you're just starting, monolithic applications makes a lot of sense. Am I clear? Does it make sense? That's number one. Now let's try to move to the number 2 point. You need a monolithic applications when you want to build a latency sensitive applications. What is a latency sensitive application? Latency means, in very simple words, if I try to keep it very simple, let's say that I am interacting with an application, right? So the time I made a request and then I get the response back, right? This is, let's say, the T1 time and this is the T2 time. So this T1 plus T2 time that it took me to load the content of an application, that will be considered as a latency. So let's say that I'm trying to build an application where latency is very important. I want the response to be very fast. In all those kind of situations, monolithic applications makes a lot of sense. Can you guys tell me why this could be the case? Can you think of? See, if let's say that I'm not following a monolithic application, right? So let's say inside one, let's say this is a this is a normal non-monolithic app. So inside a non-monolithic app, what happens is that, let's say that there are multiple applications, right? So in the monolithic application, there could be like service 1, there could be service 2, and there could be service 3. All are hidden, right? So in this case, whenever a client makes a call, right? Whenever a client makes a call, this S1 might call S2, S2 might call S3, then the response will come back, then the response will come back. All of this is a network call. And then finally the response come back. Now, when you start working in the industry, you'll realize that network is one of the slowest operation that to happen, right? So in the case of the non-monolithic application, when the small parts are located on different machines for the entire time, or let's say this is the time T1, this will be the time T2, this is time T3, this is time T4, this is time T5, this is time T6. So the total time that it will take to do the response will be the sum of all of these, T1 plus T2 plus T3 plus T4 plus T5 plus T6, right? A lot of network hop is happening. But the same thing if I try to do in the case of the monolithic world, what will happen? In a single machine itself, I will have all these services, S1, S2 and S3. And now if they have to communicate, they can do through the inter-process communication. यहाँ पे network hop की जरूरत नहीं पड़ेगी. So when a customer tries to call in the monolithic way, it can directly come and get the data very quickly because it's an inter-process communication. I'll give you an example. When I'm working for the LinkedIn lastly, right, we were trying to build an application which was very latency sensitive. I wanted to get a response back in less than few milliseconds. And that's when, when most of the companies application that we have built are based on the microservices or service-oriented architecture, we had no other choice but stick to the monolithic. So when you have a latency as a big concern, monolithic is a place which can help you achieve that because it avoids network hop. Am I clear, people? Does it make sense? Am I clear? Does it make sense, everyone? Is this point clear that how, when it is a latency sensitive applications, how the monolithic applications makes a lot of sense? Fair enough? right? आगे बढ़े? Cool. So now once we have understood this, let's talk about more. The another scenario where monolithic makes a lot of sense is again in the situation when you have security concerns. Some time back, one of the politicians in the country was suggesting that instead of a single prime minister, we should have the multiple prime minister concept. Now, right now, let's say that I have only single prime minister in our country. What happens in that case? All our, the jet security forces, all our security guys, right? They kind of protect our PM because he's a single PM in the country, protects our PM from all the directions. No stone is unturned, left, which ensure that the prime minister is secured. But let's assume that that prime minister, that politician urge is kind of met, right? And instead of a single PM, we start having the multiple PMs. What will happen in that case? Let's say there are multiple PMs. And let's say the number of the security forces that we have is limited, right? So the same security force, I'll have to minimize the security of each of the prime ministers, right? Right? So let's say 2 comes for each of them. Now, since 2 security forces are, covering the multiple PMs of the country, chances of the security breach is higher. Or else you will have to, deploy more money. You will have to hire more security agency and security will become more expensive. The same logic applies in the case of the monolithic applications also. In the case of the monolithic world, what happens? Everything is a single machine, right? In the monolithic world, if I go and talk about, everything is in a single machine itself, right? Service S1, service S2, service S3, everything is in a single machine. So only thing that I need to do is that put all my energy and resource to protect this machine itself, secure this machine itself. So security monolithic applications are much simpler, less expensive and less complicated. But instead of that, if I have the multiple machines to do it, multiple places to do for, there are so many moving pieces, the security becomes much more complicated. And that's why you will find that even today, all the super secure applications across the world, if you look around the companies who have, they stick to the monolithic applications. Many banking systems you feel, they still feel that monolithic is much more easy for them because that provides them additional security. Am I clear, people? Does it make sense, guys? Fair enough? Is everyone clear on the security concerns? So when you have a security concern, you want to make a super secure system, monolithic applications makes a lot of sense. Perfect. Now let's try to move on further. Now this is more of from my experience perspective, right? When you make use of monolithic application, sir, this leads to less confused developers. When you go and make use of monolithic application, इससे जो आपके developers होते हैं, they are less confused. What is the meaning of that less confused developers? Let's say that you're working in a company. In a company, there will be different types of individuals. Those who are freshers, those who are, the old timers. So what happens? When you try to make use of the newer architectural patterns, the latest architectural patterns, which are not well understood by your employees, and you just try to enforce them. Let's say that I have a people who are working for the last 10 years, and they didn't get chance to upgrade themselves what is happening latest in the industry, and you force them that, okay, guys, let's start working on the microservices architecture itself. Now, if your employees are not smart enough, they are not in pace with what is going in the industry, and just force them to use something, for example, microservices architecture, instead of doing good, that would be more worst for your company. Because they will not understand what it is, how it is implemented, and they'll end up doing mistakes, a lot of mistakes there, right? But when you make use of the monolithic application, since it is there for quite some time and it is simple, the chances are whether someone who has come in your company or someone who's experienced, it's much easier to go and implement. So when you're not very sure about the upskilling of the teams of your company, right? आपको नहीं पता कि आपके टीम के आपके peers जो हैं, आपके जो लोग आपके साथ काम करते हैं, if they are smart enough, if they are latest, they are aware about the latest thing, going with monolithic, because the teamwork, working for a company is a teamwork. Monolithic will help you get an environment where the developers are less confused and they get you the better productivity. Fair enough? Am I clear, guys? Does it make sense? Hanji, is everyone clear till this point? Right? So these are the scenarios, right? So all these 5 points that I talked about, last 4 points that I talked about, will help you decide when you go in a company, depending on the situation where you are, it will help you decide ki bhaiya, should I use monolithic or not? Is everyone crystal clear till this point? Is everyone who's watching this live or you're watching it recorded, are you crystal clear that in what situation, when I should go for a monolithic application? Very nice. Cool. Now, so far we have been talking about all the good things. But that would have some challenges to the monolithic. Because if monolithic was, sarva sampan, if there was no faults of monolithic, we could have never been to the other architectures, right? So definitely there could be some challenges, some problems, some limitations, because of which we had to go beyond monolithic. So now let's try to talk about the challenges of monolithic architecture. Let's try to talk about the challenges of monolithic. The first biggest challenge of a monolithic architecture is that, number one, it's not flexible, or it's sometimes very slow in going to production. What does that mean? Let's try to take this, example in terms of a web application, monolithic web application itself. So let's say that if I have a web application which is monolithic. Now in this, I have a front end, I have back end, I have the database code. Now let's say that I just change a small color of the button from the red to the green. Only one line of change has happened in the CSS of the front end. But since it is a monolithic architecture, everything goes together, the entire code piece has to be deployed. Small change in front end, but that is making you deploy the entire code base. Now, since everything has to be deployed together, this will take a long time. If you are not managing your deployment well, this might also make, will mean that your application is unavailable. Right? So when you make use of a monolithic application, even a small change will require the entire thing to be redeployed. And since everything has to go together, deployment will take time. If you are not managing your application well, maybe the time when it is getting deployed, your application will be unavailable. These are the most common causes or challenges with the monolithic application. Am I clear, people? Fair enough? That's one. Let's try to move and talk about the next challenge. The next challenge of monolithic application is that, number two, the monolithic application has a single point of failure. Since everything is in a single machine, sir, since everything that you see is in a single machine, right? Let's say that front end is also here, back end is also here, Data storage layer is also here. If for some reason ये machine goes down, if for some reason power failure happens, something it goes crashes, everything goes for a toss. Nothing is working, neither front end nor back end nor database. Everything goes for a toss because everything is at one place, either all in or all out. So that's another big anti-pattern, the challenge that you have when you have a monolithic application. Very nice, Kaushik. Fair enough. So that's another challenge of using monolithic application. The third big challenge of monolithic application is again very practical. I'm telling you with my experiences in the coordination. Now let me give you a situation how it happens when you start working for a company, right? So let's say that this is a monolithic application, right? This is my front end layer. And then I have this is called as a back end layer, right? Let's say that on the front end, there's a girl called as Shivani is working, right? And on the back end, there's a guy called as Vishwa is working. Let's assume that. Now, since it is the same code base, back end and front end are related because it's a monolithic architecture. Every time, let's say that Vishwa has to make change in the back end, he will have to keep Shivani posted. He will have to take permission from the Shivani that Shivani, I want to plan to make this change because are you ready for it or not? So let's say that Vishwa was planning to work on an issue I1. For this to be implemented in the backend, there was dependency from the front end also. So he goes to Shivani and says that, hey Shivani, can you help me with this change? Now Shivani was already working on some another piece. She is saying that for the next 1 week, I'm not available. I'm working on another critical piece. Only after 1 week, I'll be able to do it. So for that entire 1 week, what will happen? The Vishwa cannot do anything. He's simply waiting. He's kind of blocked by Shivani. Are you trying to understand the point? And here, when you work in a company, these kind of human behavior also comes into the angle. So the next time, let's say that after a month back, Shivani had a similar problem. Shivani had to make some changes, right? This time Shivani came to Vishwa. Vishwa ko yaad hai, last time when I called Shivani, she made me wait for 1 week. Let me do this now to her. So now Vishwa says, main bhi busy. I am also busy for the next 3 weeks now. Only after 3 weeks I'll be able to make this change. So again, now Shivani will have to wait for 3 weeks. And these kind of human conflicts are very common in the industry, guys, I'll tell you, because humans work in the company level. Since there's so much of tight coupling, this leads to a lot of delays. So that's another big problem of coordination that this monolithic applications bring to the table. Does that make sense? Am I clear, guys? Bolo, samajh mein aa raha hai ye human angle? Is this human angle clear to everyone? Boliye. Fair enough? Cool. This is the third point. The fourth point. Many of the people feels that monolithic applications are difficult to scale. कुछ लोग इसको इस तरीके से टर्म करते हैं, monolithic application can't be scaled. Monolithic application can't be scaled. What do you guys think? Is it true or it is false? Can you guys put that into the statement? I have a question for you guys. What do you guys think? क्या monolithic application को scale किया जा सकता है? Can we scale a monolithic application? Yes or no? Put that into the chat section. I want to hear from you guys. What do you guys think? Can a monolithic application be scaled? I'll just wait for a few minutes. Let me see if you are able to make the think of the answer. Kiran is saying that monolithic application cannot be scaled. Many of the people are saying no. So this is one of the big misconcepts which goes around among the people when they say that, the monolithic application cannot be scaled. Actually, the answer is the monolithic application can be easily scaled. Answer is yes, sir. The monolithic applications could be scaled, but there are challenges to it. Let me try to show you that how it could be scaled. No, let me take with the help of example. Let's say that, let's take an example of Times of India. Have you guys heard of Times of India? Times of India के बारे में सबने सुना है? So when the Times of India was started, let's assume that it's a fictitious story. ठीक है? There's nothing to the reality. So I'm telling you a fictitious story. When the Times of India was started, in the beginning, Times of India used to print only the sensible news. Times of India only used to print news which was to awaken the morality of the citizens of the country. And since that was making sense, very less people were watching it. And that's why Times of India started with something called as a monolithic architecture. Monolithic architecture. Let's assume that. And what will happen in the case of the monolithic architecture? The monolithic architecture will include so it will have something called as front end also in the same machine, back end also in the same machine, and the database also in the same machine, right? This is how it all started. Okay, because in the beginning there was less crowd only, the people who were watching this was very less, right? So this is how it used to work for Times of India. Okay. But suddenly when it was happening, this is the initial state of the Times of India, where everything was in a single machine, front end, back end, and database layer. And there were the limited customers of the Times of India, so the limited customers were there. But then one fine day, a new intern came in Times of India. And it was a great turning moment for the entire history. That new intern said that, what the crap are you guys doing? Why not do you add masalas and the images? And that day, all the people in TOI, they heard him. And then from that day till today, there's no looking back. And suddenly the Times of India found that there's a huge rush of the people watching the TOI newspaper now, right? Front end, back end, database. And now the huge rush of the people started making use of the Times of India website. All this is a fiction story, guys. There's nothing reality to the reality. Now, since more load on the company came up, so the Times of India has to scale their system because the more customers are coming on the website. How can they do it? It was very simple. How can they do it? In order to scale it, instead of using a single machine, they will now have the multiple machines, right? They will now have the multiple machines. They will now have the multiple machines. And then they will keep somewhere here in place here something called as a load balancer. Load balancer. And now the people, large number of the people can go and watch it. So scaling is not a problem. You have it in the multiple machine and you can scale even a monolithic application. So scaling is not a problem. Scaling is not, you can easily scale it. So saying that the monolithic application ko scale hi nahi kar sakte is a wrong statement. We can easily scale it. Use multiple machines and make use of a load balancer. You should be able to scale it. But there is a challenge in this. There is a challenge in it. Which kind of student can watch it? Everyone. I'm trying to keep it from the basic. हर कोई student को थोड़ा interest है IT field में, you can watch this from the starting and it will make all sense to you. So everyone can watch it. There's some challenge in it. So if you look around in this Times of India website, right? So any application that you see here, right? There is a front end, there is a back end, and there is a database. Now, if you talk about Times of India, it's more of like a read-only website. It's a read-only. It's a read-only website. Correct. So when I say that more and more people are coming, they are coming only for the read. So the load has only increased on the front end. On the back end and on the database side, because no writes are happening, the load on the back end and the database has not increased. The load has only increased on the front end. But because we had a monolithic architecture where everything was in a single machine, right? We had a front end also in the same machine, we had the back end also in the same, and we have the database also at the same place. When I was scaling back end also. I was scaling backend also. I was scaling database also, which was not needed. So one of the challenges of the monolithic architecture is that whatever that you want to scale, that you need to scale anyways, but other unwanted things also get scaled unnecessarily, which kind of cost you the resource cost, and it also add unnecessary complications. So one of the biggest challenges of the monolithic architecture is that you cannot do selective scaling. You definitely can scale, but unwanted scaling comes as a part of which could be expensive, which could be complicated. So the challenge is that you cannot do, what is the takeaway from this? We cannot do selective scaling. We can't do the selective scaling is tough. Am I clear, people? Does that make sense, everyone? Am I clear till this point? Bolo bhaiya. Is everyone clear till this point? Fair enough. Now let's try to move on. What are the other challenges? The other challenge of a monolithic application again is that you are forced to use a single stack. Since everything goes in the same code base, in the same code repository, right? Let's say that I have a service S1, I have a service S2, I have a service S3. Since all of them goes in the same code base, same repo, all of them typically in the monolithic need to be written in the same language. They need to have the same tech stack. Even though you know that something could have been built in a better way, there's much better open source solutions for it, you still sometimes you'll have to compromise because of the architectural decision that you have taken. So that's another big challenge or the flip side of a monolithic applications. That's another big flip side of monolithic application. Am I clear till this point? I think we have enough points now around the monolithic that we are able to decide that what are the situations when we should avoid making use of monolithic applications. Fair enough? Aage badhe. So now I think we have done enough discussions on the monolithic, and it's time to move to the next part of the architectural revolution. What next came into the picture which took the entire world by the storm? Shall I go ahead there, people? Right? So the next thing that people got used to, with all these challenges, people started talking about the another way of dealing things. And the next things that came into the market, which took the world by storm in terms of architectural patterns, that was called as SOA, which stands for Service Oriented Architecture. Service oriented architectures. In the service oriented architecture, it is based on a philosophy of give and takes. As per the SOA world, there are only two types of applications in the world of SOA. One type of application will be called as service requester. And another kind of applications will be called as service providers. They're saying that the entire world of the applications will always have two categories of application. One who requests for some service and the one who provides that service. Okay? They said that how basically in the monolithic world everything was together. SOA says that we are more practical, we are the modern, we are believer of nuclear family. We believe that if you stay separate, there is less fight. So again, from how our society has evolved over a period of time, SOA is also evolved version of monolithic. So it believes in nuclear family. It says that instead of having all things together, a typical SOA, if I go and apply on web application, right? If I go and apply on a web application, a typical SOA will look like that. In the case of service-oriented architecture, I might have front end on a separate machine. I might have the back end written separately on a different machine. And I have a database hosted entirely on the other machine, right? Each of them might have the different code base, different tech stack 1, here it could be the tech stack 2, this might be done with the help of the tech stack 3. And all of them might be connected to each other over the network. So SOA says that ki bhaiya sab alag alag raho, everyone should live separately, there should be separate code base, there should be separate deployment, there should be separate machines. Follow the funda of nuclear family, stay separate, don't fight. That's what a service-oriented architecture says. Am I clear to this point? Does it make sense? है ना? Service-oriented architecture कहते हैं भैया अलग अलग रहो. Let me give you an example. That let's say that I am working for Amazon. Let's assume that I am working for Amazon. And I have a problem to solve. Let's say that I have to ensure the checkout experience of a customer. I have to ensure a checkout experience of customer. How do I do it? How do I define it? Let's say that if I have to go and do it in the world of the service-oriented architecture, let's say that if I'm following the SOA to do it, what I'll do is that I'll define the different services, right? So I could have the different services. For example, I might have something called as the cart service. I might have something called as a checkout service. I might have something called as an authentication service. I go and call it as an auth service. I might have something called as an inventory service. I might have something called as a payment service. And I have something called as a shipment service. Okay. And now the flow could be what? Let's say that someone is trying to buy something, right? So the user first goes to the checkout service. Checkout service might make a network to the checkout service. Before the checkout happens, checkout might make a call to the auth service if the user is valid or not. Auth service returns a response that okay, user is valid. Then it will go and do a final check if the item is available in the inventory or not. Only if it is confirmed that the sale will happen. If that has happened, then a soft lock will happen on the item, and then it will make call to the payment service. Payment service will give a confirmation to the inventory. A hard deduction of that item will happen. And then finally the checkout service is complete. It will make a call to the shipment service so that the item shipment starts. So what you see here, for each of the functionality, I have a different services which might be written in all the different languages. It might be possible, bhaiya, ki this has been written in JavaScript. Maybe this is written in Java. maybe this piece is written in Python. It's pretty much possible, right? So when you try to break the entire process into the smaller pieces, smaller chunks, each of them could have their own tech stack. Each of them could have the separate deployments. Each of them is independent to each other and they're talking to each other over the network. They're talking to each other over the network. This kind of architectural pattern is called as service-oriented architecture. This kind of architectural patterns is called as a service-oriented architectures. Am I clear, people? Does that make sense, guys? Clear hai? Is everything crystal clear till this point? I'll take extra time, but make sure that everything is done. एक single session so that you don't have to do things again and again. आपका ये सारा architecture के around जो concept है, I'll make sure that we are done in this one single shot. But for that, I need a support. I don't want you guys people to move around. Make sure that you watch it in a single shot and get this sorted. Am I clear till this point? Perfect. Very nice. So in the world of SOA, there are only two types of applications. The applications 1, application 2. One of the application is called as service requester and another is called as the service providers. Beauty about this is that both of these applications could be written in the different programming language. Say for example, this could be done, say for example, in Python, and this could be written in Node.js. And these applications, they talk to each other over network. These applications, they go and talk to each other over the network. They do it over the network. Now, sometimes the application which initiates the call, the first call the application 1 is making to application 2. So this guy application 1 is also sometimes called as client. The person who starts the call, who makes the request, who is a service requester, they are also sometimes called as client. And the application which returns the response, who does the processing, who are the service provider, they are also sometimes called as the servers. Just a common name, I just wanted to make sure that we are clear with this. So the system which initiates the call, you go and call it as a client, and system which returns the response back, they are called as servers. I'll get you this, you don't need to take this, the screenshot. Once this is done, we'll upload the, the attachment of this in the comment section of both LinkedIn Live as well as the YouTube. So you can download it. So aap bas focus on the session. I'll get all the slides to you people. Don't worry on that. Fair enough? Cool. So we have understood SOA. So we have understood what part? Now logical part of that is why or when, right? Or I say that what are the advantages of using SOA? Advantages. So let's try to understand that what are the advantages. The first biggest advantages of SOA, I think you should be already clear, is that I should be able to selectively scale. What does that mean? Let's say that in my application, I'm following a SOA, right? If I'm creating an application, I'm following a SOA. I have multiple services that I build, S1, S2, S3, S4. Now, if I know that the load is only getting higher on S1, I can just go and scale S1 because S1 has a different code base. S1 is hosted on a different machine. So I can just go and scale S1. No, I don't have to touch anything around S2, S3 or S4. Right, so I can do the selective scaling. So one of the biggest advantages that you get as when you do service-oriented architecture is that scale only that thing which is needed. Other thing you keep as it is so that you don't involve extra complexity and extra cost into the game. Fair enough? Cool. So that's one, selective scaling. Now let's talk about the another part. The second advantage of service oriented architecture is that it gets you a lot of flexibility. Now if I take the same old example, right, let's say that there's a component S1, there's a component S2, there's a component S3. Now since all these threes are independent on each other, here Shivani is working and here let's say that Vishwa is working. And if you remember the old story, the fight between Shivani and Vishwa in this monolithic world, even though these people don't like each other still Shivani is not going to impact the work of Vishwa because he's working on an independent piece S3 which has nothing to do with S1. Similarly, Shivani work won't be impacted by Vishwa because he's working on an independent piece S1 which has nothing to do with S3 now. So even the humans, they tend to fight. This whole architecture allows people to work in silos, work in parallel so that they don't impact each other work out. So that gets you a lot of flexibility. You can work on your own piece without impacting others. That's another advantage that you get as a part of service-oriented architecture. Fair enough? Do you guys agree with me? Does it make sense? Bolo. Is it clear, guys? Bataiye. Awesome. Now, the third point. Multiple tech stack could be used. Multiple tech stack could be used. Since in a service-oriented architecture, it allows you that there is S1, there is S2, there is S3. You know that since all these three are hosted on multiple machines, you can make one in Java. You can make another in JavaScript. You can make the third in Python. Right? So all these possibilities allows you to choose something which is best for your project. You are not constrained here that everything has to be done in the same language. You can choose different languages for doing different things. So that gets you a lot of flexibility. So you can choose multiple tech stack. What you can do? You can choose multiple tech stack. Am I clear, people? Does it make sense? Tech stack का मतलब होता है, Raman, that for example, let's say that I'm trying to become a MERN stack developer, right? So in the MERN stack, what do I use? I make use of MongoDB. I make use of Express. I make use of React. I make use of Node.js. This is what the hottest stack right now in the world of full stack development. So these all things when you go and make use for building an application, this is termed as tech stack. This is termed as tech stack. Right? That's the meaning of the tech stack is. Okay. Great. Another advantage of the service-oriented architecture is that there is no, I think it's fourth point, no single point of failure. Since I know that in the service-oriented architecture, there will be multiple components, service S1, service S2, service S3. All of them are actually talking to each other over the network. So even though if this component goes down, S2 can still behave to work, S3 can still behave to work. Just because S2, S1 is down, other component does not stop working. So there is no single point of failure, which is another added advantage of using service-oriented architecture. Fair enough? Very nice, Hamid. Absolutely correct. Another important advantage of the SOA is that it gets you a lot of reusability. Since everything is broken down into the smaller chunks, the same code piece could be used at multiple places. The same code base could be used at multiple places. Say, for example, if I'm using a service-oriented architecture, so auth service is a single service. Now, this auth service could be also used during the process of checkout. It could be used in the process of checkout. This could also be used in the process of registration. This could also be used in the process of login. This could also be used in the process of audit confirmation. Right? Since what we have done is that we have tried to break down into the smaller pieces. When you make use of service-oriented architecture, it helps you to create a reusable code. You write it once and use it at multiple places. So that's another added advantage that you get as a part of service-oriented architecture. So by now, I believe all of you have got a very crystal understanding कि भैया monolithic when to use, monolithic when not to use. What is a service-oriented architecture? And what are the situations or the advantages or when you are gonna make use of SOA, service-oriented architecture. Am I clear till this point, people? Does that make sense, Bolo? Guys and girls, ladies and gentlemen, sir and madams, is this clear till this point? Awesome, very nice. Now, once we have done this, obviously nothing is perfect. So this might also have some kind of challenges. And that's why I believe we move to microservices. So let's try to talk about what are the challenges. I think these are very obvious now. So far with all the points that we have discussed, this has become very obvious. So let's try to talk about what are the challenges. Challenges of SOA, which is service-oriented architecture. What are the challenges? Let's try to understand this one after another. One of the biggest challenge of service-oriented architecture is that one. I'm sorry, sir. One of the biggest challenges of the SOA is in the service-oriented architecture, first of all, the few challenges would be like security is complex. When you have the multiple components, the security definitely becomes complex. We have already talked about it in the previous, monolithic game itself. When you have multiple services, S1, which is running on one machine, there's another service S2, which is running on another machine. There's a S3, which is running on all the other machine. Now, managing the security all around these, managing the security of this, managing the security of this, all of them, because there are so many moving pieces, it becomes complicated. And it also becomes expensive. Right? It becomes complicated and it also gets expensive. So this is the first big concern of SOA, right? That is, security is complex. Am I clear? Does it make sense? Similarly, the another challenge of the SOA would be that, you would be easily able to guess by now, is that not suitable in the latency sensitive application. Latency sensitive application. SOA is not suitable in the case of the latency sensitive application. We only talked about that. In the case of the SOA, what will happen? There will be multiple applications, right? There will be application S1, there will be application S2, there will be application S3, there will be application S4. Whenever a client makes a call, right? Whenever a client makes a call, the request might go to S1, S1 will redirect to the S2, S2 might redirect to the S3, S3 to S4, then it comes back, and then it finally comes back. So inside this route, there are a lot of network hops. Which is time consuming. So whenever you make use of service-oriented architecture, you might have to do a trade-off with latency constraints. So that's another challenge of using the service-oriented architecture. Fair enough. Latency मैंने already बताया है, Shiv. No, I have talked about this latency previously. Let me quickly do it. Let's say that, this is you called an application. You first make a request and then the response come back. Let's say this is time T1, this is time T2. So So total time that it took T1 plus T2 for you to get the response is called as latency. The time that it takes, in very simple words, there are more detailed definition of the latency. We can talk on that separately in a latency topic itself. But normally on a high level, how much time the application takes to respond to your request, that's typically is called as latency. Am I clear? Save, sir, is it clear now? Perfect. Cool. That's another challenge. Let's try to talk about another challenge of service-oriented architecture. The another challenge of the service-oriented architecture is that testing is complicated. Testing is complicated. Now, what happens in the case of the service-oriented architecture? I have the multiple services S1, S2, S3, S4. They're complex system. You have to, when you are doing the testing, you have to test all of them. You have to test all of them separately. And then you all have to do a integration testing. This itself poses a lot of challenge. I'll give you one example. Can you guys tell me, let me play a small quiz. Can you tell me, this is a very famous social media which was acquired by the Facebook some years back. Can you tell me which, and this social media is famous for putting up the stories. Let me know that how many seconds you guys need to guess this company name. It's very simple. You do use day in, day out. Can you guys tell me the name of the company I'm talking about? This was a company bought by the Facebook, famous for making stories. Which company that I'm talking about? Can you guys quickly put that into the chat? What company I'm talking about? Very nice. So Raman has got it right. It's Instagram, right? So when Instagram was bought by Facebook, Instagram also vouched that, we are following service-oriented architecture. We are great. And definitely Instagram has a great tech stack itself. But since Facebook itself is also a very good service-oriented architecture pattern that they are following, they inherently has built a kind of a testing platform just to do the load testing and integration testing of their distributed services that they have. So as soon as the Instagram was onboarded, and why I'm telling you this story is that testing is not easy and efficient all the time. So all this time Instagram were feeling that they have tested all their applications. But as soon as the Facebook acquired them, within the first week itself, Facebook tried applying their testing framework on Instagram. And what it did is that it tries to randomly put some of the machines down to check if Instagram is still available. And because Instagram was not tested properly previously, that testing framework brought down Instagram well for quite few hours, and it was a big news in the market. Within a first few weeks of the the onboarding of the Instagram on the Facebook, the Instagram was down for a few hours because of the testing efforts from the Facebook itself. So I'm trying to put this example to you to put the emphasis that testing a distributed system, testing a service-oriented architecture when you have the multiple services involved, it's never easy. It's very tough and complicated. Fair enough? So testing is complicated. Number 4. The other challenge of this is that, this leads to confused developers. If you have not asked your developer to spend enough time on understanding what a SOA is, and you just force them to use it, it will lead to more problems than benefits, right? And that's why I go and call it that this leads to the confused developer. So make sure that you give enough time to your developers so that they understand what the problem is and then try to solve it from the core itself, right? So that's another challenge of using the service-oriented architecture. So far, sir, what we have done is we have understood monolithic, and we have understood SOA. These two things we have understood very well, right? We have understood what, we have understood why, and we have also understood why not, right? We have understood bhaiya hai kya ye? We have understood what are the advantages or scenarios when you should make use of either monolithic or SOA. And we also talked about the challenges that when I should not use it, what are the problems of using it. Fair enough. Everyone is crystal clear till this point? Bolo. Guys and girls, sir and madam, are we all clear till this point? Is everyone clear till this point? Bataiye. Fair enough? Awesome. Now let's try to move to the buzzword of the town, which everyone is talking these days. And that guy of the town is microservices. Microservices. Is this a new term? Is this the new guy? Is something which has new? Now, a lot have been talking about microservice in the last few years itself. Microservices is a no new term, sir. There's nothing new about microservices. Microservices are just more refined version of, they are most the refined version of service-oriented architecture. Or I also say that they are more restricted, more strict version of service-oriented architecture. If I give you an analogy and then we'll talk more on that. If I talk about SOA and if I talk about the microservices, right? SOA is more of like your parents. You have rules, but if you don't follow those rules very religiously, parents will scold you, but they will never disown you. Let's say the parent says that you have to come house early, you don't drink, but let's say some nice day you are found drunk also, they will just scold you, but they will not disown you. So they are not very strict. On the other hand, if I talk about the microservices are like modern partners, modern husbands or the wives. That if you go and breach certain rule, people are so impatient today that they will simply say that, okay, tata, bye-bye, divorce, right? So microservices are very strict. So microservices is no new term, sir. It's a very well-defined or more fine-grained versions of service-oriented architecture. So in order to understand the difference between the SOA and the microservices, let me take an example. And with that example, I'll try to make you understand so that you become crystal clear that what microservices are. Microservices are actually a service-oriented architecture only, but they're more refined rules. So let's try to see that with the help of an example itself. So let's say that on the left-hand side, I have something called as SOA, right? So let's say in the SOA, I have three services. Let's say I have three services, service S1, service S2, and service S3. Now, service-oriented architecture says that all these services should be talking to each other over the network, right? They should be talking to each other over the network. Now, service-oriented architecture says that, the two application, there's no hard and fast rule. The multiple application can share the same database. S3 has a different database. So in the service-oriented architecture, I have service S1, I have service S2, and I have service S3. And these services are talking to each other over the network. If you can see, services are talking to each other over the network. And here the database is being shared. If the same thing has to happen in the case of, in the case of microservices, we still will have the three services, service S1, service S2, and we have service S3. Now, microservices says that every service has to be fully independent. There should be no dependency at all. For example, in this case, even though I say that S1 and S2 is independent, but they have the same database, sir. Let's say that because of the S1, there is too much of load on database and database crashes, it will start impacting S2. I know that, on a high level, we are saying in the service-oriented architecture, the services are independent, but they may not be independent in the true sense. For example, here, S1 is different tech stack, maybe S2 is different tech stack. There are two different applications. But since they're sharing the database, let's say that because of S1, the database goes down, S2 will get impacted. There is some level of dependency. Microservices tries to avoid that only. Microservices say that, bhaiya, there should not be any dependency at all. So for every service, I should have a separate database. Every service, no two services should share the same database. All of this should be an independent piece. All of these three services should be independent piece, fully independent. Right? And if they have to talk over the network. How normally that happens in the case of they can talk only over the network. So that's the difference between the microservices and the service-oriented architecture. Microservice is the more fine-grained form of service-oriented architecture, more strict, very well defined. Every individual service should be fully independent. When you make sure that, that's typically you are following a microservices architecture. So microservices and service-oriented architecture, not much difference. Every microservice architecture is a service-oriented architecture, provided you have ensured that every single service that you have built is fully independent and is not impacting the other services. That's what it is called as microservices. But I'll put it very practically. If I talk very practically, the lines between the SOA and the microservices are so thin that they are always overlapping. Many of the times in the industry, I have seen that people are only using SOA, but they're calling it microservices. Or sometimes they're making use of microservice and they call it SOA itself. So it's one of the most highly misunderstood terms. But I'm fair enough that all the people who's watching this, you people have a very crisp understanding now that what monolithic architecture is, what service-oriented architecture is, and what are microservices. Am I clear, people? Does that make sense? Fair enough, everyone. So with this, that's all I wanted to discuss in the today's session. I hope you liked it. If you have liked this session, the only thing that I expect from you people is a little support, because that motivates me to come again more and more live and teach you people. Right? So if you like it, please share it with your friends. Put some comments. If you're watching it live or recorded, share it on the social media, tag me over LinkedIn and let me know that how it helped you. And tell me what are the new set of the sessions that I should bring for you people. I'm already recording few of the things. In next few days, you'll get a recording, one shot for Node.js. So all those people who are watching from the full stack domain, I'll make sure that you get a very deep understanding, totally free of cost on YouTube. I'm recording that in next few days, it will be coming up. I'm also planning a series on data structures and algorithm in Java. So all those people who are planning to make it big in the product-based companies, FANG companies, I'm planning in a long format where, each one-shot video for each single topic in data structure. Like, one topic on Java, data structure for arrays, another for the linked list, another for the graph. So I have a lot of things in plan. I'm also planning to bring a playlist on the system design, right? High-level design, low-level design, all the concepts which are needed for the system design, right? So many things are planned. But the only thing that I need to do all these stuff for you people is to understand if it is actually effective to you guys. So I need a little support and love on the social media. If you feel it is helping out, please share it with your friends and make sure that, you are tagging me so that I know that it's helping out. And if that happens, I promise you that I'll keep coming more frequently live. A lot of videos will be coming on this PW Skill Tech channel. And I'm fully committed to make sure that, everything you get is of the best of the quality. I hope this was helpful, people. Okay, there's a follow-up question, like how the microservices connect. So let's say that if I have a service S1 and there's a service S2. Previously in the past, we used to use a concept called as SOAP. In the past, we use a concept called as a SOAP, which stands for the Simple Object Access Protocol. that made use of XML. It was very famous once upon a time. But because of the XML thing, since it was slow, since it was heavy, people moved beyond SOAP, and then people started using something called as REST APIs. REST, one of the biggest advantages that it brought was it was flexible. It was not rigid. Most of the time you see that it makes use of JSON. It can use other also. It can use text. It can use other file formats also. It was fast, comparatively fast and light. But over a period of time, the people realized that there are even few challenges with the REST itself. So they moved to something called as GraphQL. That's another way of doing the interaction between the services in the microservices world. Not only GraphQL, the people have further talked about that how can we further reduce the the amount of data that we are transferring to the client and the servers, and that these days they have started using something called as gRPC, and for that they make use of the company called as protobuf. I am planning to create a detailed tutorial. I think these two things are already covered. Most of the people are already aware of. These are the new emerging things. I'm planning to bring a detailed tutorial that how do you things in gRPC, how do you do things in the GraphQL, right? Both in the GraphQL and the gRPC, how do we do things? I'm planning to record something and get you either in the live session or the record. So these are the different ways through which these S1 and S2 can talk to each other over the network. These are the possibilities that are there. Okay, so I'll just take this question because it's already quite late. So I have worked for multiple companies, right? So for example, when I started working for the Oracle, there mostly the tech stack was Java, right? Oracle is a tech giant, so I worked in Java and Oracle a lot while I was working with Oracle. Then I moved to PayPal. PayPal, I worked more of like started with C++, and then I work as a full stack developer, and that's where my interaction with the Node.js started. So I worked like a full stack developer in the financial domain in the in PayPal. Then I moved to the Amazon, and Amazon I worked very successfully in the cloud world. And after Amazon, I moved to Walmart Labs. There I work on Scala, Python, a big data world, right? Data science world. And then finally, I was working for the LinkedIn, where again I work on multiple tech stack, be it Python, be it Scala, be it the Node.js, right? And then I also work in the field of the machine learning and data science. So through it, last 13 years, I've been very fortunate to work on world's most scalable applications. I'll try to bring more examples, as and when I teach more you people, I'll try to bring more examples of the real world working and see how that could be incorporated in the world of the. Cool, sir. Thank you. Then with that, I'll say bye to you people. I hope it was helpful. And with the promise that I'll again come back with many videos. I'll expect you people to put the suggestion in the comment. I'll try to look into that, and based on that, we'll plan our next live session. Till then, keep learning, guys. Thanks a lot for joining today. Thank you.